So this is a pretty standard statics introductory problem. If you just got a bunch of forces on something and it says find the resultant force, and you're like, okay, I can do that. So I'm going to start off by, well, actually, eventually what I want to do is I want to put this into SolidWorks and do it for me, but I have to make sure I know what I'm doing. But anyway, I'm going to resolve these into the x and y components. So I've got my x and y, my y axis here. So if I look at the 100 Newton force, I can say, okay, well, 25 times 4 is 100. So 24 times 4 is, I think, 96. So that means the 100 Newton force kind of separates out into a 96 and then 28, because 7 times 4 is 28. Then I have the 500 Newton force going straight up. And then over here I have a 20 degree. Unfortunately, this means I need to use a little bit of a calculator thing, which I can pull up. But basically, I've got a, I've got a triangle that is a 20 degree here, 600 here, so I have opposite, or the adjacent is the cosine, so 600 cosine 20, and the opposite is 600 sine 20. And of course I don't have those memorized. So I've got 600 times the sine of 20 and 600 times the cosine of 20. So I've got 205 and 564. So I have, I forgot which ones they were. This must be 205 and 564. So if I add up all the sum of the forces in the x direction, I end up with a negative 96 and a positive 564, which I can do. I've got negative, well, yeah, that minus 96. So 468. And then the sum of the forces in the y direction, that was beautiful. Some of the forces in the y direction are going to be 500 up, 28 up, and 205 up. And I just want to use the exact number, so I'm going to pull up the calculator again. So I've got 500 plus 28 plus the 205, 733. All right, so I can say the resultant force is going to be the square root of the sum of the squares. Well, so basically there's two ways I can do it. I can say it's 468i plus 733j, or, so that'd be the vector version, or I can get just the scalar version. It is going to be the square root of those two squared. So the square root of this squared plus this squared, and answer 870-ish. Okay, but now the question is, how would I actually do this in SolidWorks? So that's where we're going to go next with this. So here we are in SolidWorks. I'm going to start a new part, and I'm going to make sure that I'm in the right units. I'm going to go to the options, document properties, units, MKS, Newton, or meter, kilogram, second, perfect. All right, now I want to actually create this part. So I'm going to go, let's see, I just want to kind of do something. I'll go on the top plane, create a sketch, right click, create a sketch. I'm just going to make a little box, and this is just a box for all the forces to hold on to. It doesn't really matter how big it is because I don't really care. I'm just going to arbitrarily set it to a certain size. And hit there, exit sketch. There's no minus sign, so it's fully defined. I'm going to extrude by 1. I'm just going to make a box. Beautiful. Okay. Now what I want to do is I want to make a point for all of these forces to attach to. So I'm going to select the top, and I'm going to hit reference geometry, point, and it's automatically going to put a new point in the center of that face. So that I know what I'm doing later, I'm going to rename that point force point. Now I have a force point, and it's beautiful. Okay. I want to also recognize that I'm going to have a plane that all those forces are going to go to, and right now my planes are not in the right places. So I need to create an additional reference geometry. I'm going to create a plane, and the plane is going to go actually in between. So I'm getting it to rotate by pressing on the scroll wheel and rotating there. And so I can tell it to go mid-plane, so it'll basically go through the center, which is perfect because I made it a square, and that was kind of intentional. I don't need to make this bigger, but I can just if I feel like it. But there we go. All right. Now I have a nice plane to put all my forces on. Perfect. And let's see, what else I need to do? Okay. Now I'm going to go ahead and put in the lines where my forces are going to go, and then I'm going to talk to those lines later. Now, in order to do that, I'm going to make a sketch on that new plane. So with plane 1 selected, I'm going to right click and I'm going to say do a sketch. Now, for each one of those, I'm going to have one coming straight up. So I click force point. If I go straight up, you see the little yellow thing that's like straight up, and it says 90 degrees, and I'm like, yay! Now this doesn't actually matter how big it is, but I'm going to click Smart Dimension, and I'm going to dimension it at, well, sorry, click yes for the line, Smart Dimension it. It doesn't matter how long it is because this is really just going to be something I'm using for construction. That just looks bad, so I'm going to make it 0.5. All right, beautiful. I'm going to make another line coming out kind of this way. I can hit escape to get out of the line thing once I've got a line that I like. Now for the dimension, I know this is 20 degrees off the normal, so I can click the line here, and then it's kind of hard to get in there, but ooh, no. So I might need to scroll in. So to do that, I actually scroll the mouse wheel the opposite direction you think you should. I'll start off by clicking this line down here, then this one, and no, not 0.74. Well, okay. Since it's not letting me go that way, I'm just going to go the opposite way, from here to here. And instead of saying the other way is 20 degrees, I'll say this way is 70 degrees. Because I'm too lazy to figure out what's going on. And then I'll go ahead and set an arbitrary distance for this guy is 0.5. And if I hit F, the key F, it's going to scroll out and I can see where those two are going to go. All right. Now I'm going to put my last line in, starting again at, I'm going to scroll in so I can see what's going on. There's that force point, and here is this guy. Now, this one doesn't have an angle. Instead it has that it's a 724.25. The way that I can achieve that is I can actually go point, point, and now see if I go like this, I can do that dimension. This is this way. So I know that this one is the 7. Now I don't want it to be huge, so I'm just going to say 0.7. And then I know that the one from here to here again, but in this direction, would be 2.4. So I still, whoa, have that 724.25 actually, just so it doesn't look so stupid. I'll do 0.24 and 0.07. So I still have the right ratio. And I got that 724.25. So now I have all 3 lines that I'm going to need to put in my forces. Exit sketch. The sketch is fully defined, which makes me super duper happy. So these are where my forces are going to go. The next thing I'm going to do is I'm going to do a simulation study. Now, here's something important. If you don't see that, you need to go check in with your add-ins. If you look at your active add-ins, you need to have SolidWorks Simulation. If you don't have it selected, if you don't even have it as an option, then you can't do any of this, so sorry. But anyway, simulation study. I'm going to do a static study, and this is just, I'm just trying to find a resultant. It doesn't matter what I call it. But it makes me happy to name things properly. While I'm doing this, I'm going to go ahead and save this. And now I can put in these forces. So I'm going to right click external loads, go to force, and I'm going to specifically tell it I want to be in a selected direction. So see the little pointy thing? That means that I want it on this point, on that point, and along the line of that. Now you see that it's actually facing the opposite direction because I wanted it to face up. So I'm going to come over here and click reverse direction. I want the total force to be 500 newtons. Perfect. Check. All right, I'm going to add another force, starting at this point in a selected direction along this line. And this one is going to be 600 newtons. And of course it's facing the wrong direction. Check. One more force, right click force, selected direction, starting from the force point. If I can get to it. If you can't click on it, you can also expand this here and click force point there. And then selected direction is along that sketch line. Looks like it's probably facing the wrong direction again. It's kind of hard to tell actually because the box is in the way. but see, I can hover over and kind of get an idea. If I hit reverse direction, it goes the opposite way. But this one is going to be 100 long. And I hit go. Now you might say, I can't see that other force and it's kind of creeping me out. One of the things I can do is I can right click this box and I can say hide. There, and now I can see it. Now I can see where that force is. It's just the way that it has it drawn in. Now I want to see this again, so I can come back up here to this boss extrude, which is the box, and then see how it says show, so I'll show it again. Now the only thing is if I do the study right now, this box is floating in space. If I put all those forces on it, it's just going to run like crazy. So I want to come down here and I want to fix it. So right click fixtures, fix geometry. That just basically means that that face cannot move. The last thing I have to do is I have to define the material. Since this isn't an actual finite element analysis, I don't actually care what happens to the box. I just want to know what's going on with the points. It doesn't matter what material I pick. Now I want to run the study. Okay, now it's important to notice that if I go over to displacement, it's showing that the box has moved approximately not at all. So these are in 0.0 or times 10 to the negative 4 millimeters, so this thing really isn't moving, so really don't freak out. You can just unclick deformed results so that that doesn't bother you anymore. So if I'm only looking for the results, I can right click, say list result force. And so then here I can say I want to see the free body forces. If you don't see the free body force, that means, I should have probably said this, whenever you come to the study itself, you can right click it and go down to properties. You want to make sure that you have compute free body forces checked. So if you don't, make sure you've got that selected. So I'm going to come back to the results, list result force, and I want to see on that force point. And I think I just have to click something else in general. There we go. Okay, so I see that my X direction is 468, which is exactly what I had before. The other one is 434. Now that's pretty close. Last time what I had was 433.2, so they got 434. That's still super duper close. And they do have a Z direction, but you have to remember that this is a computer and it's using different methods. It's not solving it the same algebraic way that we are, so it does get slightly different answers. But the total resultant force is 871. Ours was 870. So if I take our, stop that. If I take our answer minus their answer, which is 871, and I get an error analysis by dividing by the real answer, I can see that the percent error is actually less than 0.1%, so I'm generally okay with that. Now it's also showing moment reaction forces and stuff like that, but they're all extremely small, so that's again not something that we want to worry about. We just want to look at that resultant. So this is some pretty cool stuff here. So here's one more that you could try. My recommendation is, now that you've kind of had a little bit of experience, to pause the video and see how far you can get. So try to do that. If not, just follow along. So we've got these two forces. We have this force, we'll call it F1 and F2. Now F1 looks like this. It's at 200 pounds. Now we're in pounds. This is a 45-degree triangle. So that means that this side, well, its two sides are 100 square root of 2 and 100 square root of 2. Then we have the 600-pound one. And since it's at 40 degrees, that 40 degrees is the same as this 40 here, the opposite is going to be 600 times sine of 40, and its adjacent is going to be 600 times the cosine of 40, like that. So we can go plug these into our calculators and get answers, because that's what it's all about. So our two, I could say F1 is going to be 141 and 141. So it's negative 141 backwards along the I direction, and then 141 forward along the J direction. And then F2 is given by 600 cosine 40. And the other one is 600 sine 40. So we've got 460 and 386. So 386 backwards. And what was the other number? 460 down. So I can add those together and I can get a decent bit of statics. So I've got the 141. Well, it's really negative 141 minus the 386. So negative 527. And I've got a positive 141 minus a 460, and that's minus 318. Meaning that my resultant force is the square root of the sum of the squares. I don't know if it's actually gonna, I'm probably gonna have to tell it to go ignore those negative signs. Like that. 616. And this is in pounds. So I have a resultant force of 616. Now let's make sure we can do this in SolidWorks. Now as we're getting started with the part here, we actually want to go to our options and make sure that we have inch pound seconds. So I'm going to go ahead and I'm going to create my little box of stuff. Smart dimension. Smart dimension. Exit sketch. Extrude. One. Beautiful. Okay, remember we're going to put our reference geometry, we're going to put our point in the center. Oops. Yay, and that's our force point. You don't have to call it force point, it just helps you remember later what's going on. Now, let's see, we need a plane going through that, so reference geometry, not force point. Right click, delete, ka-choo, mid-plane, ka-chunk. Beautiful, now I have a plane. Whoop-shoo. Okay, now let's see, I want to draw, I'll go back to normal. I want to draw on that plane where my forces are going to go. It's going to be amazing. Now, we have no forces going straight up, but we have two forces that are going to be going off like that. Now, a problem that we ran into on the last one was we couldn't get a dimension between the bottom part, but I'm going to try it this way. Ah, there we go. I just had to find another point. So, oops, except this is supposed to be the other direction. So let's just for fun show how you would do that. We could put in a reference line going straight up because it's not there now because we weren't using it. So see if I can click on this line and I can actually say it's for construction, which means I'm not really using it for anything except to look at, basically. So now I can smart dimension from that line to here, and it's 40 degrees. And I can smart dimension from that line to this line, even though it's not in the same plane, and say that it's 45 degrees. And everything is perfect. Exit sketch. Oh, it's not fully defined. Okay, so I'm going to go back, right-click, edit sketch, because I do like things to be fully defined. I can see where it's not defined because I can change the length of this line. So I can go ahead and just smart dimension it. It doesn't really matter. It's just, stop it. It's just makes me feel better to know that there's nothing undefined, especially since I'm running a simulation study. I really would feel better if everything was fully defined. Okay, so there we go. There's the points that I want. Now I'm going to create a new simulation study, a static simulation. That's fine. All right, so I'm going to add external load of a force. select a direction starting at the force, starting at the force point, and yes, along that face. No, along this line. There we go. And it's, of course, the wrong direction, because it's always going to be the wrong direction for who knows what reason. And then I hit yay, and then I'm going to do another one. And it's also going to be a selected direction, and if only there's a way to make that automated, right-click clear, click this button, and I've got 600, and it's actually going into the plane, which is kind of what I wanted, so it's kind of nice. Why does it say newtons? I thought I was in inch, pounds, seconds. Let's see what's going on. Maybe it's too stupid to know that force is in newtons. That'll be something that will have to be solved another day. Oh, there we go. There we go. Pounds force. 600. Now I feel better. No, quit changing it. I told you what I wanted to make. That's weird. It was showing up right there. Let's see what happens. Okay, I'm not entirely sure why this is happening, but if I edit it and I type it in here, it doesn't like it. But if I come over here and say 600 pounds, it seems to take it. So there's our 600 pounds. Now I gotta make sure I change my other one, because that would be very silly. So I'm gonna go back to metric. I wonder, English, I wonder why it doesn't do that. 200, and of course I'm gonna be stupid again. And there we go. So I have the 200 and the 600. Remember on the fixtures, hit F to get it into a nice little place. Right-click the bottom, or not right-click the bottom, click on the bottom. Fixtures, you want to fix the geometry there. And that should be good enough. I'm going to go ahead and save it. And I'm going to now, I have to identify my material and run the study. Doop. And right-click results, and I can turn off the deformed result. I'm going to go ahead and save it. And my right-click results, list the results in force, free body force. I want to see what's going on with this point. And for some reason, it always wants me to select this. I'm sure one day I'll figure that out too. I want the units in IPS. Alrighty, so we got 527 and minus 318 and 616, which is dead on to what we got whenever we solved this by hand. So this is actually kind of cool, is that we can do something on paper and then put it in a computer and get the exact same answer both ways.